In this video, we're going to be talking about the parts of a chemical equation. So in this over here is a chemical equation. We have the reactants on one side, the products on the other, and we have a reaction arrow in the middle. So first, let's talk about the parts of this chemical reaction and identify them. So the first part over here is the coefficient. The coefficient, as we learned in math, is basically a number that forms right before the variable. In this case, the variable would be the element. Now, let's take this example, H2. H2 has this small subscript over here. This subscript basically means that instead of one hydrogen atom, there are two hydrogen atoms. If I had something like H3, then there would be three hydrogen atoms and so forth. But this coefficient here, what that means is that the coefficient and the subscript multiply together to be able to create, which is basically nothing but H4. So in other words, there are four hydrogen atoms over here. So, and I already explained what the subscript is. It's the small number that's right below the element. And all this means is that instead of like this oxygen, for example, instead of being one oxygen element, the two represents that there are two oxygen elements. Now, we have this state of matter in parentheses, and the G stands for gas, the L stands for liquid, the S stands for solid, and the AQ stands for aqueous solution. Now we have this reaction arrow. The reaction arrow shows that a chemical change has occurred. And when a chemical change has occurred, it turns from the reactants into a product over here. The reactants is where we have the elements formed up and together create a chemical reaction to create the products. Based on the chemical reaction, we can either see these compounds combining or separating. It's basically the type of chemical reaction, but whatever it is, the reaction arrow shows that there was a chemical reaction between the reactants and now the products. So we identify in the state of matter that this turned into a liquid, meaning that we already know this is water from H2O. Thing is, how would we know how to calculate this entire thing? So let's keep some track. We know there are four hydrogen, and since there are two over here, two oxygen, as we saw in the subscript, there are two oxygen. So what that means is the amount of the same elements that are located in the reactants have to be the same in the products. It's just the product shows it in a different way. So we have 2H2O. 2H2O, the H2O means water, and we have two which is basically the coefficient. So when we have 2H2O, and if we're putting the coefficient on a compound instead of just a singular element, the coefficient acts for the entire compound. So the 2 multiplies with this 2 over here, so that gives us 4 hydrogen. And for the oxygen, even though there's no subscript, we can basically see that there's 1 over here because there's 1 oxygen, and the subscript over here confirms that there's 1 oxygen. So just 1 over here. So then we have 2 times the 1, which gives us 2 again. This shows that there's the same number of elements, or the same number of oxygen and the same number of hydrogen in the reactants as there are in the products. So this means that this chemical equation is true and isn't false. In summary, we have the coefficient, which all that happens is the coefficient multiplies with the subscript to be able to identify the number of hydrogen, the number of the same elements that there are. Now, you might be wondering, why do we have a coefficient, and like why do we make it so difficult? Well, let's say instead of wanting to write H2 plus H2, we can simply write it as 2H2. So in other words, instead of just showing that there's 4 hydrogen through this way, we can simply show that there's 4 hydrogen through this way. Next, we have the subscript, which also explains how many of the same elements there are. And then we have this reaction arrow, which shows a chemical change. And in these parentheses, we have a state of matter. It can be classified as gas, solid, liquid, or aqueous solution. And lastly, we have the products over here, which to be able to create a true chemical equation, they have to be able, the number of elements that are located in the product have to be the same as the number of elements located in the reactants. So So this is all about the parts of a chemical equation.